Welcome back to the matrix playlist. In this video, let's understand how to perform matrix addition manually using basic mathematics and coding approach. To begin with, if you want to add two matrices, they must have the same dimensions, that is, the same number of rows and columns. If the dimensions don't match, matrix addition is not possible. As you can see on the screen, each element from one matrix is added to the corresponding element in the same position of the other matrix. That means index ij in matrix A is added to index ij in matrix B. Now that the manual concept is clear, let's move on to the coding approach where we will understand this process using an algorithm, a flowchart, and finally write the code to implement it. Let's now walk through the flowchart for performing matrix addition. We begin with the start block. The process kicks off from here. Then we move on to input two matrices, matrix 1 and matrix 2. Next comes a very important step. We check whether the dimensions of the two matrices are the same. That means rows 1 should be equal to rows 2 and columns 1 should be equal to columns 2. If the dimensions do not match, the flow moves to the right and we display an error message since matrix addition is not possible in this case. But if the dimensions are the same, we continue downward and initialize a result matrix, one with the same size as the input matrices. Then we proceed to perform the addition by iterating through each element and storing the result. After that, we print the resulting matrix to show the final output. And finally, we reach the end of the flow chart. Now let's take a look at the algorithm for matrix addition. I won't go into a detailed explanation here since we've already walked through the logic. Just follow along on the screen. So what's the difference between an algorithm and a flowchart? An algorithm is a step-by-step written instruction, more like a list that helps us understand the logic behind a problem. A flowchart, on the other hand, is a visual representation of that same logic using symbols, arrows, and diagrams. It makes it easier to visualize the flow of execution. So, basically, both represent the same process, one in text and one in diagram form. Next up, let's move from theory to practice and implement this logic in code. First, let's define a function that takes two matrices as input. Now, before we perform any operations, it's really important to check the dimensions of both matrices. That means we need to make sure the number of rows and the number of columns in the first matrix exactly match those in the second matrix. To do this, we use len matrix. Length of matrix, okay? Here first I want to check length of matrix 1 is matched with length of matrix 2, or we use len matrix to check how many rows we have, and for the number of columns we use len matrix 0. Because we are looking at the number of elements in the first row, which tells us how many columns are in each row. Sorry, here we have to put matrix 1 because we are checking with matrix. We are checking matrix 1 with matrix 2, right? If the number of rows or columns doesn't match, we should raise an error because addition is only valid when both matrices are of the same size. Raise value error. Invalid dimensions. Initialize rows and columns. Length of matrix. Length of matrix. 0. Sorry, 1. I'm here using one of any matrix, okay? Result. Next, we create a new result matrix and we initialize it with all zeros. This result matrix will have the same number of rows and columns as the input matrices. These things previously I have explained in my earlier video. I have explained it very clearly why we are using row matrix, row list, and why we are appending this row into this result list. Everything I have explained in my previous video. Once we have that set up, we use nested for loops to loop through each row and each column. Inside the loop, we simply add the corresponding elements from both matrices and store the result in our result matrix. Rows for J in range, columns, result ij. should be matrix matrix 1 ij plus matrix 2 ij. This is what we need as output, right? So we have to return the result. After all elements are added, the result matrix will contain the final output of the addition. Then we can define two example matrices as input, call our function with them, and print the result using a simple for loop, printing each row one by one for easy readability. Let's create matrix, okay? A. Let's initialize B matrix. Here I am using num instead of row because I already have used row, so really confusing. Finally, to make our program more robust and beginner friendly, we can wrap everything in a try except block. That way, if the user inputs mismatched matrices instead of crashing, our program will display a clean and user friendly error. E print error. Using this kind of structured approach makes your code more maintainable and easier to debug. And using a try-catch block is definitely a best practice in programming. Okay, let's run it. Finally, we got the exact output 10, 10, 10 because here 1 plus 9 is 10, 2 plus 8, 9, 10, 3 plus 7, 10. Likewise, we are getting exact output.